Hey, welcome to this spiral video. My name is Sarah Powell and I work at the University of Texas at Austin. And in this video, we are going to think about the length model of fractions. That is fractions according to their length. Most often we think about this along a number line orientation. And today we're going to compare Cuisenaire rods to fraction tiles. We are going to do this comparison with two different fractions. First, let's talk about using both of these manipulatives for the fraction 4/5, and then let's talk about using these manipulatives for the fraction 4/9. Let's get started. Let's first show the fraction 4/5. If I'm doing that with my fraction tiles, I would show my whole, and then I would divide that whole into 5 equal parts. And then what I would want to do is focus on the numerator, which in this problem is 4, and then I want to show 4 of those 5 1/5 parts. So there I showed the fraction 4/5. Now what would that look like with my Cuisenaire rods? Well, I could get out my Cuisenaire rods and I could show a length of, here I've got my 5 white rods, and then I could say, well, that's equivalent to this yellow rod here, so there's the fraction 4/5. But the really cool thing about the Cuisenaire rods, as we have seen in other spiral videos, is that I can show 4/5 in multiple ways. So here I could say, well, there are 5 red rods, and that's equivalent to this orange rod here, so there is the fraction 4/5. So while the fraction tiles can only be used to show 4/5 in one way, Cuisenaire rods can be used to show 4/5 in multiple ways. Now let's look at this fraction 4/9. Now you might have a set of fraction tiles and you might be saying, well, Sarah, I've got a problem. I actually do not have a set of fraction tiles that show ninths or 1/9 pieces. And you're exactly right. Most fraction tile sets do not come in ninths. So that means we can't use our fraction tiles, but we can very, very easily use our Cuisenaire rods. So what do I want to do? Well, I want to make a length with these white rods, or white, you can call them cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to show that that's equivalent to this blue rod here. And then I'm going to show 1, 2, 3, 4 of those. I'll move those to the side there. So there I very easily showed the fraction 4/9. So if you're thinking about different manipulatives to use, for the length model you can use the fraction tiles, and you can also use the Cuisenaire rods. But as you can see, the Cuisenaire rods add a level of flexibility, so I can show the same fraction in multiple ways. And the Cuisenaire rods can also be used to show fractions that have, I will say, denominators that aren't always the most common denominators that we work with, such as fractions where you want to show ninths, or maybe fractions with 7ths, 11ths, and so on. Thank you for tuning into this math spiral video. We'll see you in another math spiral video very, very soon.